Two-stroke never die. As we all know, the two-stroke engine is one of the most popular engines. Unlike the more complex four-stroke engine, the two-stroke engine is characterized by its captivating simplicity, which has won the hearts of motor vehicle and small power tool enthusiasts since ancient times. In addition, its rich history and efficient operation make it a popular choice. The two-stroke engine adopts a very simple combustion cycle, which ultimately produces responsive acceleration and high power in a compact size. However, for all its advantages, it is certain and well known that this engine also has disadvantages, including high emissions and higher fuel consumption compared to four-stroke engines. But did you know there's still a rare type of two-stroke engine that's seldom exposed? One example is the Twingle split single engine, or we can call it the two-stroke engine with one cylinder and two pistons. As you can see, this engine emerged in the 20th century and was originally developed in Germany. In this video, we'll explain what a Twingle engine is, or how to abbreviate it as a twin single engine. Okay, let's get to it. Let's start by taking a quick look at Adalberto Gelli, who played a big part in the Twingle engine. Adalberto Gelli was an Italian engineer and innovator born in 1886. He was one of the first to develop two-stroke engines, especially with the Twingle engine. Gelli graduated from the Polytechnic University of Turin in 1911, where he focused on mechanical engineering. After graduating, Gelli started out working at a few different automotive companies before going out on his own. Then in 1912, this veteran started developing small two-stroke engines that became the basis for many of his innovations. One of the most important breakthroughs he created was the Twingle-designed two-stroke engine, which has two pistons working in one large cylinder, or as we might say, two connected cylinders. This design makes it more efficient than conventional two-stroke engines, especially at low revs. His real career kicked off in 1919, when Adalberto Gelli set up his own factory, Gelli Motorcycles. The company quickly gained a reputation for its innovative two-stroke engines. One of Gelli's most famous engines was the 350cc engine with a scavenging loop system. It provided high performance and exceptional efficiency. And this motorcycle was called the Gelli 350 Sport. To get a better understanding of this innovative engine, let's first take a look at its physical aspects. First, let's take a look at the most striking part, the piston. As the name suggests, Twingle is a combination of the words twin and single. Inside the cylinder, we find two pistons supported by one connecting rod with one pin, with the same cylinder but interconnected holes in both cylinders. Then, in each cylinder, we find portholes. One cylinder has an intake port and the other has an exhaust port. And for the rest, like the crankshaft and others, they use the same components as typical engines. Before we get into how the Twingle engine works, let's take a look at some of the complaints or shortcomings of two-stroke engines in general. One of the main issues with two-stroke engines is the high level of emissions. So what causes the high emissions in two-stroke engines? First, incomplete combustion. Another thing to consider is the loss of fuel and lubricants. Quality of fuel and lubricants. Another thing that can cause high emissions is an inefficient ignition system. Inadequate exhaust gas filtration. Finally, we have to consider technological limitations. But if we talk about the Gelli two-stroke engine or the Twingle engine we mentioned earlier, the emissions that are typically high in conventional two-stroke engines will be compressed by the Twingle engine. Alright, let's get into it in depth now. To cut to the chase, let's just dive right in and explain how it works. After looking into it, it seems that in broad terms, its operation may still be similar to conventional two-stroke engines. But what makes it different is how it handles the intake and exhaust processes in the Twingle engine. As you can see in the pictures of both engines, when fuel goes into the cylinder in a conventional two-stroke engine, the new fuel is pushed out along with the exhaust gases. However, in the Twingle engine, the fuel is blocked by the partition wall between the two pistons, so when new fuel comes into the cylinder, it pushes the exhaust gas towards the exhaust port in a systematic and precise manner. This makes the engine more efficient, stops fuel from escaping, and keeps exhaust gases out of the cylinder. Also, this partition wall helps save fuel. During combustion, the two pistons increase the surface area, which helps dissipate heat more widely from the cylinder. This makes it ideal for air cooling applications. However, since the combustion area is larger, the compression process is going to be less efficient. But since the fuel used back then was octane fuel, this issue didn't cause any problems. And even then, the Gelli 350 motorcycle, which produced 20 horsepower at 4,500 revolutions per minute, racked up plenty of wins in racing competitions, both nationally and internationally. After we looked at the history again, we found out that vehicles with the Twingle engine weren't just made by Gelli. Even Triumph used it in one of their motorcycles, called the TWN Cornet 200, which was made from 1946 to 1957. But there's one difference between these two Twingle engines in the connecting rod. The Triumph Twingle uses a Y-shaped connecting rod to hold both pistons. It also has a different layout for the ports. The intake and exhaust ports are on the same cylinder, and the transfer port is split into two holes. This helps direct the exhaust gases and improves scavenging of the cylinder. It also provides good power and fuel efficiency. As time went on and technology changed, the Twingle engine got a few updates to make it better. Now let's switch gears and look at the Twingle model with the pistons placed parallel to the direction of the engine's rotation. This Twingle engine is different from the last one because the pistons are now placed parallel to the direction of the engine's rotation, rather than parallel to the crankshaft. What are the advantages of this design? To see the difference, let's compare it with the Twingle engine from Triumph. You'll notice a big difference between these two engines when it comes to the intake and exhaust processes. As we mentioned earlier, the Triumph Twingle engine pushes exhaust gases towards the exhaust port during the intake process. However, since the opening times of both ports are the same, some of the incoming gas will still be expelled towards the exhaust port, which is something to think about. But it's different with the engine we're about to explain now. Because the piston is positioned parallel to the direction of the crankshaft's rotation, the opening times of both the exhaust and intake ports will be different. This means that the exhaust port will open first, then the intake port. So with this process, the exhaust gases will be expelled first, and then the intake port will be opened to introduce fresh gas into the cylinder. What do you think? Absolutely more efficient, right? Given the unique nature of the Twingle engine, it's interesting to note that in the United States, the Twingle engine was also used in a motorcycle company. Specifically, it was used in a motorcycle called the Sears Allstate 250, which was made in 38,000 units between 1953 and 1970. But what makes this engine different from the ones we've already talked about is that in this motorcycle engine, it uses two connecting rods connected to both pistons in one big end. One advantage is that the piston is more flexible than the Y-shaped connecting rod in previous engines. Secondly, we can move the slave connecting rod pin, which lets us adjust the opening and closing timing for its ports. It makes you wonder if the Twingle engine is only for two-wheeled vehicles. The Twingle engine has also been used in three-wheeled vehicles, specifically in the microcar ISO Isetta. This car, often called the bubble car, has a front opening door and a folding steering wheel. It has a 236cc engine with 9.5 horsepower, and of course it uses the Twingle engine. Thanks to this split-cylinder design, the ESO Isetta microcar got great fuel mileage and was one of the best in its class. Later on, the Isetta was made in lots of different countries by different companies using different engines. Some even used four-stroke engines, like in Germany or Argentina. Underscore reverse effect. After looking into it further, we found out that the first Twingle engine was actually created in 1905 by a British engineer named Lucas. However, because the crankshaft was placed out of sync, it messed with the engine's balance. Also, because it had almost the same number of components as two complete engines, this engine wasn't used that often. Alright, that's all we can cover in this video. As usual, if you have any questions or want to add anything, just type it in the comments below. Thanks for watching.